Hi students, welcome to the video lecture 5 on the topic transient heat conduction. In the today's class, we will solve the problems. So let me read first the problem. A steel plate, its thermal diffusivity is given, that is alpha is equals to 1.2 into 10 to the power minus 5 meter square per second. Thermal conductivity K is 43 watt per meter degree centigrade of thickness 2L equal to 10 centimeter. Initially at a uniform temperature of 250 degrees centigrade is suddenly immersed in an oil bath at TA is equals to 45 degrees centigrade. Convection heat transfer coefficient between fluid and the surfaces is 700 watt per meter square degree centigrade. So how long will it take for the center plane to cool to 100 degrees centigrade? What fraction of energy is removed during this time? And what is the temperature on the surface of the plate? So initially the steel plate is at temperature of 250 degrees centigrade and it is suddenly immersed in an oil bath at a temperature of 45 degrees centigrade. Convection heat transfer coefficient is already given. So thermal conductivity is given. Thickness, it is 2L itself is 10 centimeter. So now let me go for solving the problem data. So before starting the problem, let me write this L. So already we know that the thickness 2L itself is 10 centimeter. So therefore L will be equals to 5 centimeter. So directly I have written L here, it is 0.05 meter. Directly I have written 5 centimeter in terms of meter only. So let me come to the point afterwards here, how we have written L equal to 0.05 meter. So this thermal diffusivity is given 1.2 into 10 to the power minus 5 meter square per second. Thermal conductivity is given. Initial temperature is given. Temperature of the oil bath is given. Heat transfer coefficient is given. So how long will it take for the center plane to cool to 100 degrees centigrade? That means center line temperature he has given, that is it is at 100 degrees centigrade. So how much time it will take to reach the center plane to cool up to its 100 degree centigrade? So what is the time? How long it will take means he has asked us to calculate the time required to cool this steel plate at the center plane to cool it up to 100 degree centigrade. He has asked us to calculate the time. At this next, he has asked us to calculate what fraction of energy is removed during this time. So what fraction of energy means? So this is total heat transferred divided by maximum possible heat transferred. So Q divided by Q maximum, we have to calculate this value. And what is the surface temperature on the plate? He has asked us to calculate this value. So now as usual, before solving the problem, we have to first calculate the Biot number. So this Biot number. So Biot number is given by the formula H into LC divided by K, where LC is the characteristic length. So how we will calculate this LC? LC is calculated by characteristic length for plane slab. So this is plate, means the problem is based on slab only. So LC is equals to V divided by A, that is volume of the plate divided by area of the plate. So if we will solve this, so LC is equals to L. We have already derived it in the previous classes by dealing with the theory. So characteristic length LC for slab will be equals to L only, where L is half the thickness of the plate, where L is half the thickness of the plate. So L already they have given, 2L is given, they have given in terms of 10 centimeter. So L is half the thickness of the plate, means here L is equals to 0.5 centimeter, that is 0.05 meter. So that means characteristic length LC will be equals to L, that is half the thickness of the plate. So H is already given 700 watt per meter square degree centigrade. LC already we have calculated, that is characteristic length LC divided by 43. So we have got the value of Biot number as 0.8319 as the value. So in the previous problem, first we have calculated the Biot number. There the Biot number was less than 0.1. So therefore we have used their lumped system analysis. But in this problem, after calculating this Biot number, so Biot number value is greater than 0.1. The value of this Biot number is greater than 0.1. If the value of Biot number is greater than 0.1, then this lumped system analysis is not applicable to solve this problem. Lumped system analysis is not applicable if the Biot number is greater than 0.1. Now, if this Biot number is greater than 0.1, then lumped system analysis is not applicable. Then such problems are solved by using the charts. So before which charts we are going to use? So we will adopt the Hissler chart solution to get the value. We are going to use the Hissler charts, which are already available in your data handbook. So here, if you are using the data handbook of Hegde and Niranjan Murthy, so go for page number 52, that is Hegde data handbook. DHB, it indicates data handbook. So there you can go for chart number 6. So already they have written there, transient temperature for slab of thickness 2L subject to convection at both boundary surfaces. So totally for a plain slab, there you are going to see three graphs. So all the three graphs I have explained in this video only. So one by one we will explain it. So in the graph, let us calculate once again. Already we have calculated it. This Biot number is given by H into LC divided by K. So that value already we have got it as 0.8139, which is already calculated. So as per the graph, we require the value of this Biot number. So in the graph, 1 divided by Biot number is there. For that purpose, let us first calculate 1 divided by Biot number. It is 1 divided by 0.8139. So 1 divided by Biot number, the value is 1.229. So now he has asked us to calculate the time, how long it will take to reach take for a center plane to cool to 100 degrees centigrade. That means this is the formula, that is lumped system analysis formula. So T minus TA divided by Ti minus TA, this already we have calculated using the lumped system analysis. So this value is also available in the graph. I will show you in the graph. T minus TA divided by Ti minus TA, that will be because T is 100 degrees centigrade minus TA is 45 degrees centigrade. So initial temperature of that steel plate is 250 minus TA is 245. So my T minus TA divided by Ti minus TA value is 0.268 value. So based on this value and based on this value, from the graph I have calculated the value of Fourier number as 2.2. From the graph we have calculated the value of Fourier number as 2.2, whereas this Fourier number is given by alpha T divided by LC square. This is the formula, already we have derived it in the dealing with the theory classes. This Fourier number is given by the formula alpha T divided by LC square. So with this, let me calculate the value of T. With this formula, let me calculate the value of T. So therefore this T is given by F naught into LC square divided by alpha. So Fourier number we have already calculated from the graph, it has 2.2. So I will tell you now how we have got this Fourier number as 2.2. So this as usual we have calculated by using the formula. This also we have calculated as usual by the formula. Only this Fourier number is equal to 2.2. This value we have already calculated it from the graph. So now I will show you how we have calculated this Fourier number as 2.2. So with this, let me calculate the value of T, that is T Fourier number is 2.2 into LC square. LC characteristic length L is 0.05 whole bracket square divided by alpha, that is thermal diffusivity, already they have given in the data 1.2 into 10 to the power minus 5. With this I have got the value as 458 seconds. So now let me explain how we have got this Fourier number as 2.2. So this is the graph. I have taken it from the textbook. So in the data handbook, the same graph is available, but the graph is not that much clear. So for that purpose, this graph I have taken it from the textbook. That is Tirumaleshwar. M. Tirumaleshwar, Fundamentals of Heat and Mass Transfer textbook, M. Tirumaleshwar. From that textbook I have taken. So if we want to calculate the time, or for example if we are using the temperatures of a center line temperature, if we know, and if we want to calculate the time t, then we should use this graph only. See here in the graph here, then t naught, theta naught is equals to t of 0t minus ta divided by ti minus ta. The same graph is there, what the same equations are there, whatever we have derived it. We have derived the equation in this form, t minus ta divided by ti minus ta. So here t, they have given 0 of t. So this 0 indicates position. That means x is equals to 0. Where x is equals to 0, this indicates the center line temperature, because 2L equals to 10 centimeter. We have taken thickness as itself as 2L equals to 10 centimeter. Okay, so this 0 indicates where x is equals to 0, that means center line temperature. So in the graph, if you see here, they have written there, the notations are different there. So there they have written t naught minus t infinity divided by ti minus t infinity. The same equations. So the only notations are different. So let me tell you how we have calculated the Fourier number. So 1 divided by Biot number, already we have calculated. 1 divided by Biot number value is 1.229. That means that will be nearly equals to 1.23. So these are the graphs which indicates 1 divided by Biot number. See, you can see here, this is 1 divided by Biot number. So these are the graphs, all these graphs, these indicates 1 divided by Biot number values. See, this is 1 divided by Biot number 0, 1 divided by Biot number value if it is 0.05, if it is 0.1, 0.2, 0.3, 0.4, like that way, 1.2, 1.4, 1.6. These all the graphs indicates the value of 1 divided by Biot number. And this 0, 1, 2, 3, 4 up to 100, this indicates the value of this Fourier number. This indicates the value of Fourier number, whereas this indicates the value of solid value, that is t minus ta divided by ti minus ta, where t is the center line temperature. By solving that value, what equations we are going to get? So that indicates the value of this. So already we have calculated t minus ta divided by ti minus ta. Itself we have got it as 0.268 value. So there we have to go see here, it is 0.1, it is 0.2, somewhere it will be 0.25, somewhere here it will be 0.26. See here 0.268, somewhere I can get here 0.27. So like this way, horizontal I am coming here, horizontal line, let me draw a horizontal line like this way. Okay, then next, my Biot number, 1 divided by Biot number value is 1.23 approximately. So 1 divided by Biot number, we have already calculated it as 1.229. So this will be nearly equals to 1.23. So 1.23, somewhere it will be nearer in between this 1.2 and 1.4. So in between, like this way, I will move along this graph. I will move along this graph. So you can see here graph how I am moving it here. So 1.2, like this way I will move here, I will move here, then I will move somewhere nearer to here, like this way I will move here, I will move here. So this graph, so horizontal line, it is somewhere intersecting here, then straight away I will come from that point where that point and this point it intersects. Straight away by using the scale I am coming to the downside, that is on the x-axis line. So this point, somewhere it will be around here, somewhere it will be around here. So there might be some error in reading the readings. So some may read it as in point wise it may differ. So here it is 2, here it is 3, so here it is 2.5, so somewhere I may call it as 2.1, 2.2, so I have read it as 2.2 Fourier number, where I have read at the Fourier number as 2.2. So once again I will tell you, so this is the value of the temperature. Already we have got it as 0.268, somewhere I have marked here 0.268. So let me draw a very thin line along the horizontal line like this way. A horizontal line I will draw here like this way, and my 1 divided by Biot number is 1.23, somewhere here it is, so somewhere very nearer to this. So like this way I will come here, like this way straight away I will come here, straight away along I will move along with this graph, and I will move horizontal like this way. So where this line intersects, from that point I'm coming straight away downwards vertical towards this x-axis. So my Fourier number it will be 2.2. So in the textbook they have read it as 2.4, so there might be some error while reading the graph, so that much it will be okay, no problem. So my first part is over, that is t is equals to 458 seconds time is required to cool the center plane up to 100 degree centigrade. So now next is what fraction of energy is removed during this time. That is what fraction of energy means, we have to calculate this value, that is Q divided by Q maximum. Q divided by Q maximum. So in this, in order to calculate it is Q divided by Q maximum. So this value, this 0.7 also directly this value I have taken it from the graph only. This value, this 0.7 value, this directly I have taken this value from the graph. Let me write here graph. This value directly I have taken it from the graph. So on the graph again we require these two values, that is Biot number already we have calculated it as 0.8139, and in the graph this value is also available. So let me calculate that value also first, that is Biot number. So on the x-axis, so we are going to see these values, Biot number square into Fourier number, these values are available. So Biot number is 0.8139 whole bracket square into Fourier number already we have calculated 2.2 from the graph, so this will be 1.457. So let me now move to the graph. So how I have calculated this Q divided by Q maximum value as 0.7. So then this value we can see it afterwards. So let me come to this graph. So again here also the notations are different in the data handbook. So here in the data handbook they have given Biot number square into tau, where tau indicates the Fourier number in the data handbook. Only notations are different here. These again these all values are same, only notations are different. Biot number square into tau he has written in the data handbook, that is sketch number C, figure C. You can see here this is sketch, the similar type of sketch you can see in the data handbook, no problem. So Biot number, it is h into L divided by k. So these are the graphs which indicates the Biot number. See this here 0.002, 0.005, 0.001, 0.002. So these graphs indicates the value of the Biot number, where on the x-axis, so these indicates the Biot number square into Fourier number. So already this Biot number square into Fourier number value already we have calculated it as 1.457. Biot number square into Fourier number already we have calculated this value separately, that is 1.457. so here it is from 1 to 10, so 5 somewhere it will be here, so 1.47 means somewhere it will be here. Let me mark here, so somewhere it may be here 1.457. So my Biot number value will be 0.8139. So this is the graph of 0.5. So this is the graph of 1. So my 0.8 value, it will be somewhere nearer to this value. Somewhere nearer to this value. 0.8139. So straight away I will move vertical upwards like this way. Like this way I will move upwards up to here, and where this graph intersects. So from there I will come again horizontal towards this line. So somewhere it will be around 0.68 or 0.7. So in the already I have calculated it as 0.7. So now if we will read it as, it will be around 0.68. No problem. So there might be some error in reading this graph. I think you have understood this. 1.457 I have marked here. So straight away I am moving towards upward till it intersects the graph of 0.8139. So my 0.8139, the graph, it may be somewhere here like this way. Let me plot here. Somewhere it may be like this way, the graph. Somewhere the graph may be like this way. So from straight away I have drawn the line. I will keep the scale here. So where it intersects, from there I will come straight away horizontal to read this line. So it will be somewhere around 0.68 or 0.7. So roughly I have drawn it. So you can you can see this with the help of keeping the scale. So I think Q divided by Q maximum, how we have got this 0.7 value, I think now you have cleared it. So last one, he has asked us to calculate the surface temperature. See, again same here. Here in the graph he has given T of xt minus Ta divided by T of 0t minus Ta. So you can see here, when T of 0t in the first graph, there we have used it as the center line temperature. So here x divided by x comma t, it indicates the surface temperature. So in order to calculate the surface temperature, we are going to use this graph. In order to calculate the surface temperature, we are going to use this graph. The same explanation I have continued here. So here at the surface, if we want to calculate the surface temperature, there this x divided by L will be equals to 1 for surface. This is standard. X divided by L equals to 1. This will be standard in order to calculate the surface temperature. So these are the graphs you can see here. X divided by L, it is 0.2, this is 0.4, 0.5, 0.6, like this way. So these indicates the graph of X divided by L. So if we want to calculate the temperature at the surface, so X divided by L equals to 1. So this value will be fixed. So now again same formula, T minus Ta divided by Ti minus Ta. So this T, it indicates the surface temperature. So this Ti, it is replaced by T naught here. So in the graph, it indicates T naught temperature. T naught means center line temperature. So this T, it indicates the surface temperature. So now our main aim is to calculate the surface temperature, this T. So from the graph, see again we will calculate here. So Biot number, inverse of that is 1 divided by Biot number. Already we have calculated the value as 1.229, that is 1.23. So 1.23 somewhere it will be here. Let me mark here 1.23. So this is from 1 to 10. So this will be here 5. So this will be 1.4, 1.3. Sorry, why this is 5. So this is 4, this is 3, 2, 1, like this way. So this somewhere it will be here 1.23 means. So x is equal to x divided by L is equals to 1. So this graph. So this graph. So where this graph will intersect x equals to 1. So this will be somewhere nearer to here. So if we will come up to here, so again this will be somewhere nearer to, I think, if we'll come straight away here, so somewhere this graph will intersect at this point here. So somewhere this graph will intersect here. So again if we will come straight away horizontal towards this line, so this will be around, again somewhere it will be around 0.68. So instead of 0.68 I have taken this as 0.7. So there might be some error in seeing the graph. I think this value it will be 0.68 or 0.7 also it will be okay, no problem. 0.68, 0.69, 0.7, it depends on how accurate you read the graphs. So with that, so this T only, this T indicates surface temperature, Ta is 45. So this Ti is nothing but this value, that is center line temperature 100 minus 45, because in the graph clearly has written T of 0T. So this temperature it indicates here center line temperature. So this Ti, let me repeat, this Ti it is replaced by T naught, that is center line temperature. So this T indicates the surface temperature. So this T, it indicates the surface temperature, that only we should calculate it now. T minus 45 divided by 100 minus 45, this will be equals to 0.7 or 0.68, which is calculated from the graph. If we will solve this equation, so my temperature T will be around 83.5 degrees centigrade. So if we calculate this temperature T, that is T 0.68 from the graph, so we are going to get temperature somewhere around 82 point, somewhere we are going to get this temperature as around 82.4 degree centigrade. I hope all these graphs, I think you have understood all these graphs.